Hey class, so here's question number 78, the second one on the Wiley homework that I know has been giving some of you a hard time. And I just wanted to talk a little bit about what's going on so that you can more fully understand the problem and hopefully start to solve it. So what we have here is this kind of weird H-shaped object shown here that's broken into three equal parts, all of length L. So you could say that they each would have a mass of like m or something like that, and then the total mass would just be 3m, or you can give them each a mass of 1/3 m, however you want to do it, but we're not told the mass, so hopefully that cancels out in the process. And we're told that it starts in a horizontal position and rotates about the axis labeled here, and we're asked when it's at the vertical position, what would its angular speed be? So if we kind of rotated this on its end and maybe looked at it from the end on, just so you understand, you'd have, the end of one of the rods here, the horizontal rod here, and then here's the end of the other rod, and then your axis goes through this one here, and it's starting horizontal, and then it's going to swing downward to where it would eventually then be in a new position, maybe the final position we'll put in green, where this one's still here because your axis is still here, but the middle rod now is vertical, and then the bottom rod is down here. So that's kind of what we have going on, but the end-on view like this, where you can see it rotating, you can't notice that it's an H, which is why they give you kind of the three-dimensional view there. So when we have this situation, once again, you should immediately think, all right, we're having a change in height of our object, so we're thinking change in gravitational potential energy turning into a change in kinetic energy, and that's exactly how you'd want to start solving this one, is using conservation of energy, that your initial energy plus any work done by outside forces equals your final energy. But in this case, there's no work being done by outside forces. There's no friction or air resistance. And so all we have is our energy in this initial situation is going to equal our energy in this final situation. And since it's starting from rest, we know that both V initial and omega initial are going to be 0. So the only initial energy we have is going to be mgh, the gravitational potential energy. And so then that gravitational potential energy is going to have to be equal to our final kinetic energy at the very end, which in this case, the final kinetic energy, since it's rotating, would be rotational kinetic energy of 1/2 I times omega squared. Okay, so, there's one thing though I messed up here. Since I called each of these guys mass m, that means that this would really be 3m gh. So there's two questions we have to ask ourselves, and the real challenge of this problem is in answering those two questions. The first question is, what is h? How far does this thing move vertically? And the second question is, what is I? What is the rotational inertia of this weird H-shaped object? It's actually kind of funny. If you look at it this way, it looks almost just like an eye. So what is the eye of the eye? All right, so if we think about H, remembering back to what we talked about in class and what we practiced before, H is the height that your object moves, but with these rotating rigid body objects, that starts to get more complicated, right? And what we need to look at is the change in height of the center of mass of our object instead. So the next question is, where is the center of mass of our object? Well, there's two ways to do it. You could actually use the center of mass equation and calculate and prove this, but I'm guessing many of you can realize that if you have a rod here of mass m and a rod here of mass m and a uniform one in the middle, that the center of mass is just going to be exactly in the middle, exactly L/2 away from the axis of rotation. And so your center of mass, again, is going to be right here, and it's going to be swinging down to this location right here. So this is the path that the center of mass is going to take. And again, the center of mass is going to be L/2 below where it starts. So your center of mass then should change height of L/2, half of the length of the rod. So we got H equals L/2, that sounds good. Then we need to figure out what is our I value. Oh boy, howdy, huh? Well, our I value is going to be just a summing up or an adding up of the I of each of the different parts. So if we have this rod here, If it's a thin rod and the axis runs through the center of it, it has no rotational inertia. Okay, so we don't have to worry about that since its mass is 0 distance away from the axis. Because again, for like a point mass, right, I for a point mass equals mr squared. If r is 0, then this whole thing becomes 0. So then I is just really going to be I of the horizontal rod. So let's go ahead. My picture's getting a little ugly, so I'm going to erase some of this stuff here to try to make it a little clearer. Let's erase. This is not the fastest erasing, but that's okay. So let's just make sure we understand here. So we're going to go ahead, we'll call this rod 1, call this one 2, and this one 3. So our I, again, is going to be I1 plus I2 plus I3, and we just established a moment ago that I1 is 0. So then, when we go to sum these up, we just really need to look at I2 plus I3. So the center rod, it's a rod, a thin rod with the axis at one of its ends. So the equation for that is just going to be 1/3 ml squared. The other rod is really can be treated as just a point mass, right? Because all of its mass is evenly distributed a distance of L away from the axis of rotation. So for that guy, we can just do plus ml squared. So the total I for our entire object here is just going to be 4/3 ml squared. So if we take this equation here and we pop it in over here to our equation for figuring out the conservation of energy, in theory we should be able to solve for the omega. So I'm going to just kind of stop it here. I hope that that gives you guys enough of a start on the problem to solve it and get the green box of joy. But if you have any additional questions, just go ahead and let me know. All right, have yourselves a box-worthy day.